I've been doing a couple builds on Arbitrum Stylus, which basically is a way for us to write smart contracts in any language we like that compiles to WASM. And I decided to write them in Rust. So here, one of the first builds is connecting Scaffold Eth with Arbitrum Stylus Testnet, which is a live testnet. Here there's the block scout, and I've connected here quite a simple contract. The aim here was so that people, if they want to fiddle around with more complicated contracts, they have, a repo they can use actually in the front end this testnet. So for example, if I want to increment, this is a standard counter, I signed the signature and the number has increased, and if I go and get the transaction hash and go on the Stylus Testnet Explorer, we can see that 14 seconds ago we actually made a transaction. So this is one part of the build. And the repo, I'll link it in, but it has the essentials were that I had to introduce, I had to define the chain because VM does not actually support at the moment Stylus. So we have to, again, it's an easy repo to fork because it's really simple, but it has already everything you need. And also in the deployed contracts, you have to manually paste the ABI of this contract because at the moment the scripts that Scaffold Eth has is use Solidity. So I wasn't able to automate this part. And then in the networks, we will have Stylus. We will be using in the target network Stylus as defined here. So this is one part of the build. The second part instead is a more Rust-heavy build, and I've called it, essentially, I tried to implement the tokenized vault standard, the ERC4626 for Arbitrum Stylus. So I've developed this contract here. You can check it out. But I wanted to run through it with you here. Also because it has important functionalities in the repo that I wanted to showcase. So, well, this is the standard folder structure. Let's first talk about the SRC. It has, a main, this just calls the lib.rs, which basically here we have the Stylus SDK that imports the things that can help us to write smart contracts in Rust. And here, for example, we define the global variable. So it's a completely different way to write smart contracts. But I think it's very powerful because we can introduce Rust first libraries. And first of all, I also inherited the ERC20 Rust implementation that the Stylus team from Arbitrum has made available. So you can check it out here with a standard mint, burn, etc. So what I did was create on top of that the deposit, withdraw, after deposit, before withdraw, total asset, typically of the ERC4626. So it's the library for, let's say, smart vaults. But what is the game change here that I started to implement is, again, as I said, the Rust Learn library that we can define here in the dependencies of the cargo file, which allows us to use machine learning. In fact, here in the rebalance function of this contract, I started implementing a rebalancing, let's say, functionality that uses machine learning from that library. And again, the game change here is that usually these things would not be available in smart these libraries are not available in smart contracts because they're too heavy. Now, this has been deployed on testnet. They still have to do a lot of work to reduce the contract size, etc. But again, it shows you the power of this new way, let's say, to develop smart contracts. Again, this is a useful repo for those wanting to dabble in Rust and do these kind of things, because I made an actual hard hat folder that actually connects to, in the common.j, in the scripts, we define the ABIs. And then in the initialize, I actually am calling, if I define in my config, in my common, that here I define my contracts addresses. These are deployed contracts on Arbitrum Stylus Testnet. And in the initialize, I made a small test, basically, where I'm interacting with that contract on this thing. So if I run, if I run the script, it should it should work. I mean, it was working. Now it's not working anyways. But this is the idea. So again, here the module exports, you have to define the URLs, etc. You use your private key, and then you're good to go.